Lysine is homologous to L-ornithine and its pathways are similar to those of ornithine. It participates in forming six-membered piperidine rings. As with ornithine, the carboxyl group is lost, but the epsilon amino nitrogen is retained. Quinolizidine alkaloid. Quinolizidine alkaloid mainly found in plants of Leguminosae family. They repel the feeding of herbivores and are toxic to them by a variety of mechanisms. A number of plants containing these alkaloids must be regarded as potentially toxic to humans. Lupin alkaloids from the species of Lupinus associated with toxic properties of lupins are characterized by quinolizidine skeleton. Lupinine has a relatively simple structure derived from lysine through a series of reactions. Lysine incorporates into lupinine via cadaverine. D1-piperidine is an important intermediate after cadaverine. The two tautomers of D1-piperidine are able to couple by an aldol-type mechanism. After the coupling, the imine system is hydrolyzed, primary amine oxidized, and formation of the quinolizidine ring is achieved by imine formation. Lupinine is then synthesized by a reductive step. The pathway to spartine and lupinine requires another molecule of cadaverine, D1-piperidine, and further coupling. Spartine is a chiral diamine. It is useful chiral ligand in asymmetric synthesis. Spartine can be readily extracted from branches of Cytisus scoparius. N-methylpalatinine is an alkaloidal constituent of the bark of pomegranate where it occurs with palatinine and pseudopalatinine. The mixture of these alkaloids display activity against intestinal tapeworms. They are derived from L-lysine through a series of reactions. The name cadaverine reflects its isolation from decomposing animal flesh. In this pathway, the manic reaction involving the D1-piperidinium salt utilizes the more nucleophilic acetoacetyl-CoA rather than the acetyl-CoA. The carboxyl carbon from acetoacetate appears to be lost during the reaction by suitable hydrolysis decarboxylation reactions. Anaphorine forms in which a further piperidine ring is added via a manic reaction. The alkaloids found in the anti-asthmatic plant Lobelia inflata contain piperidine rings derived from phenylalanine via cinnamic acid. These alkaloids are produced in which benzoyl acetyl-CoA provides the nucleophile for the manic reaction. Oxidation in the piperidine ring gives a new iminium species, and this can react further with benzoyl acetyl-CoA via manic reaction. Lobeline, lobelanine, and sedamine are products from further N-methylation or carbonyl reduction reactions. Lobeline is currently used to treat methamphetamine abuse. The pungency of black pepper is mainly due to piperidine alkaloid piperine. In this structure, the piperidine ring forms part of a tertiary amide structure and is incorporated via piperidine itself, the reduction product of D1-piperidine. Indolizidine alkaloids are characterized by few 6 and 5-membered rings, with a nitrogen atom at the ring fusion. Although they are derived from lysine, their origin deviates from the more common lysine-derived structures. L-pipercholic acid is an intermediate in the pathway. This compound acts as a starter for malonate chain extension, incorporating extra C2 unit. Indolizidinone may then be produced by simple reaction. Through a sequence of hydroxylations, this compound leads to gastanospermine. This compound is also a branch point to alkaloids such as swansonine, which have the opposite configuration at the ring fusion. Gastanospermine is found in Gastanospermum australe, while swansonine is found in Swansona canescens. Both alkaloids displayed activity against AIDS virus and HIV.